So again, it's going to be absolute value inequalities. So just like we did in 9.7 and 9.8, we're going to solve it, graph it, and then write it in interval notation. So we're going to solve, graph, and write in interval notation. First one up, absolute value of x less than 3. I'm going to approach this as an algebraic problem, and then when we solve it, hopefully it'll make sense as well. So the absolute value of x, when you're looking at these, just thought of a different way. Thinking. All right. This I think will work just as good. So alternatively in my head, you can set them on two equal equations, but when you change it to a -3, we're going to have to flip the inequality symbol. I think if we approach this like in 9.8 with our compound inequalities, I need y'all to think absolute values being less than 3. What's the absolute value of 2? Is it less than 3? What's the absolute value of -2? Is it less than 3? What's the absolute value of -4? Is that less than 3? No. So all the numbers then between 3 and -3 would be numbers that when I plug it into the absolute value would be less than 3. I think this will only work though for less than now that I'm speaking it out loud too. Man, that's the approach I want to go. Will it work? Does it work every time? I gotta know. No, it doesn't. It's all right though. For the less thans, we can do it this way. So I'm going to rewrite this as -3, whatever this number is, negative of that, less than my x, less than my original 1. Now, in this case, there's nothing to solve, but if I had to solve, I would then start solving at this point. Okay, so there's your solution. All the values between -3 and 3, if I plug into here, will give me an answer that will be less than 3. So when I graph this then, will these get parentheses or brackets? Parentheses. No line underneath it gets a parentheses. And then I'm just going to shade in between. So now to write this out in interval notation, I just go parentheses, -3, comma, 3 with a closed parentheses. So there's your solution, there's your graph, and there's your interval notation. This method can work for a less than. I'll show you a different method if it becomes a greater than. Are we okay with this? All right. Let's look at a second one. I'll leave this here as well as a reference. We'll have the absolute value of x plus 1. These are absolute values. Less than or equal to 4. Okay. Because it's a less than or equal to, I can go opposite of this number. So I'll say -4 less than or equal to x plus 1. I'll drop the absolute values, less than or equal to 4. Because just like over here, whatever x is, as long as it's between 4 and -4, when I plug it in, the ultimate answer will be less than 4. So this is the 9.8. If you hadn't watched the video yet on it, you're solving this, whatever you do in the middle, you do on the outside. So how would I get x by itself in the middle? So instead of just subtracting 1 on one side, I have to do it on both sides. So it's the middle and the outside. So it's like doing two problems at the exact same time. So -4 minus 1 is less than or equal to x less than or equal to 4 minus 1, 3. So if I pick any number for x that's between -5 and 3, and I plug it in, I'll get a number that's less than 4. Largest, yeah. So that's why the -5 would come first. So when I do my number line here, 2, 3, 4. Yes, ma'am. Yeah, they would both get brackets, and then you would just shade in the middle since the x is in the middle. And so usually after you graph it, you pretty much already have your interval answer as well. Now it just becomes bracket -5, comma 3 bracket. All right. Are we okay with this so far? I won't change it. You're good. I do too. That's why when they asked me to do this for 8 weeks, I was like, okay, I'll do it. But 18, they only do the 16. Yeah. Yeah. I do see some curriculums, they have like 36 weeks. I was like, I could not imagine teaching one college class for an entire year. That's like a whole high school. Oh, okay. I didn't know that. Yeah. Yeah, no, absolutely not. All right, so let's look at a third one. We have 4 absolute value, 2x plus 3 absolute value, less than 20. So before I can make this I don't know what you want to call it, a sandwich case, compound inequality case, I still have to isolate the absolute value. So how do I get rid of that 4? Divide it. Mm-hmm. I know because it looks like parentheses, you want to distribute it, right? But we can't do that with absolute values. So 20 divided by 4, 5. Now I can write out my compound inequality. Start off with the opposite of this. So that's going to be -5 less than 2x plus 3. We'll drop the absolute value, less than 5. Are we good on this step? Okay, what do I do first? Very good. If I minus 3 in the middle, gotta do it on both sides. Good, -8. And you said 5 minus 3 was 2. Very good. Last step. So -8 divided by 2. Oh, go ahead. So if I owe $5 and I borrow another 3, I now owe $8. So remember, when you're setting it up, whatever this sign is, you want to do the opposite on the left side. So this was a 5, that'd be -5. We saw this 4 here turn into a -4, and we saw this 3 turn into a -3. Dividing it everything by 2. Correct. 2, 2, 2. Perfect. 2 divided by 2 is 1. A lot of students will tell me this is 0. So 2 divided by 2, 1. So now I got the solution. Now I can graph it. Very good. Parentheses. Shade in the middle. And then typically once you have the graph, you already have the interval. Let's look at another one. We have the absolute value of 4x plus 3 less than or equal to -3. All right, so a couple things I want you to think about. I'll give you a chance to write it first. Let me bounce back to the beginning of today's lecture. This absolute value could not equal a negative number, correct?
Yes.
Okay. With that said, can absolute value be less than a negative value? No, because an absolute value will always be possible. So when you see a situation like this, it is impossible for an absolute value to be less than a negative number. So if it is a less than and a negative, no solution. No. Greater than's a whole different question. But if it's a equal sign, a less than, and a negative, no solution. Cannot equal a negative and cannot be less than a negative. All right. All right, let's look at this question. Yes, and we'll see. I don't know. Oh, I think we get to one. Hold on. Before I get ahead of myself. Yeah, we'll get to one like that. Yeah. And she was saying that it can be greater than a negative, which is yes, but there's a quicker answer to that answer. All right, on number 5, we have the absolute value of 3x minus 4 plus 1 less than or equal to 9. So what do I have to do before I can make my compound inequality? And how do I move the 1? Nine minus 1. Now I'm ready to write my compound inequality. So I'm going to write the opposite of this sign. So that's now going to be a -8 less than or equal to, drop the absolute value bars, so 3x minus 4 less than or equal to 8. Correct. This guy, I'm going to change the sign and put it right over here. Talking about how to get rid of it or to what it's written. So technically 3x minus 4 would be 3x take away 4. Yeah. So what do I do now to solve for x? Add 4. All of it. So negative 8 plus 4. And then 8 plus 4. 12. Very good. Negative 4 over 3 cannot simplify, so we'll leave it as is. And then 12 divided by 3. 4. Very good. Negative 4/3 is like negative 1.3 repeating. So it's going to be between negative 1 and negative 2. So will I put a parentheses or a bracket? So I'm going to put a bracket roughly somewhere in the ballpark between negative 1 and negative 2. I'm coming to my 4, put a bracket, and then shade in the middle. And therefore, then my interval equation just would be bracket negative 4/3, comma, 4. Yes, yeah. So like I said, you graph it and you pretty much already just wrote out your interval answer as well. Or vice versa. If you did your interval first, you pretty much already have your graph as well. All right. So any questions on less than situations? All right. So I want to talk now about greater than situations. And then this will pretty much wrap up chapter 9. We'll take a little break and then jump into chapter 10. All right. So number 6. Same concept on all of them. We're going to solve, graph, write interval notation. So we have now the absolute value of x greater than 2. In this situation, this is what we call a or case. I cannot make a compound inequality with a greater than. I cannot say negative 2 is greater than this is greater than 2, because then that would be stating that negative 2 is greater than 2, which is not a true statement. So in this case, I'm going to write this out as 2 separate equations. We will have x will be less than negative 2, and x is greater than 2. So a couple of things to point out here. One equation will look exactly the same, just like our regular absolute value equations. The second inequality, I will flip the sign, just like I did with the equations. But when I flip the sign, I have to also flip the inequality symbol. So if we bounce back a couple of slides ago, right here, when I broke this out into 2 separate equations, one stayed the same, one became a negative on the right side. So that's basically exactly what I just did here. One stayed the same. This one now has a negative on the right side. But because of the rules of absolute value or of inequalities, since this became a negative, I have to flip the inequality symbol. So now we have this or this. So when you have a greater than situation, you have an or situation. So these are actually already solved. So let me graph it so you can kind of see what's going on. Notice these guys make an arrow in the direction that they shade. So at negative 2, I would actually shade to the left. And it also gets like a parentheses. So I'm going to put a parentheses and shade to the left. Then I'm going to go to 2, put a parentheses. I'm going to shade to the left. So with or cases, I like to call this the wing case because it looks like you have wings. Versus compound, you have like looks like a sandwich case, like it's squished between two things. That's how I look at it. What you want to call it's completely up to you. But with a greater than sign, you'll have an or situation, and you'll have it where it's graphed in opposite directions. So if we think about this, let's take -4, which is somewhere out here. I want to plug it in. What's the absolute value of -4? 4. Is 4 greater than 2? So that's true. Let me choose 4 over here. What's the absolute value of 4? 4. Is 4 greater than 2? Yes, but let's make sure we didn't make any incorrect errors here. Let's take -1. Absolute value of -1. Is 1 greater than 2? No. So basically, when you deal with a greater than situation, it's everything on the outside. So less than, we can do all these little sandwich cases, and all our graphs look like this. Greater than is an or, and they have like a wing case where they're like this. All right, let's definitely do some more. For greater than, yes. Oh, you're right. So, okay, yeah, so this is the solution. This is the graph interval equation, interval notation. So this would be negative infinity since this is the left side of the graph. And remember, infinities always gets parentheses, comma, -2, parentheses, since there wasn't a line underneath my inequality, union, so it looks like a U, but with like the out of tail. This right here means union, which again is like an or situation. So it's this or this. And then I write the other half. So that would now be 2, comma, infinity. And they'll pretty much, I want to say all, but they pretty much all look like this. The only thing that will change is these guys, depending on what number you get and if it's a bracket or parentheses. But it's usually always a negative infinity here and an infinity over here when dealing with a greater than symbol. Okay. Now let's do number 7. Absolute value of 2x plus 7 greater than or equal to 3. The absolute value is isolated. So now I'm going to separate my two equations. One will stay the same. One will change signs and flip the inequality symbol. Okay. Once we're here, we just solve it like normal. What do we do first? Subtract the 7. Three x or 3 minus 7, sorry. Very good. Oh, you said 10, didn't you? It's okay. You're gonna have it. You got this. So if you have $3, you owe someone 7, you still owe them $4. So now what? Divide by 2. So I get perfect. How do I solve this other side? That one's -10, yes. Yeah, I got you. Now what? All right, so now we're going to graph that. All right, it doesn't matter which one you graph first. You can graph this one, you can graph this one. So I'm going to start with -2. It's being shaded, it's telling me it's pointing to the right. So is -2 going to get a bracket or a parentheses? bracket, and then I'm going to shade to the right. -5, parentheses or bracket. Which way will I shade? To the left. Everything you own is to the left. Or whatever the song goes. There you go. So now, how do you write that as a interval notation? Use this as a guide. So it'd be -infinity first with a parentheses, comma, -5 with a bracket, then the U, bracket, -2, perfect. So when you're writing a or situation, which is what a greater than will give you, it's everything to the left. So it's all the negative numbers. So that's going to be -infinity up to -5. The bracket tells me it's included. And then from -2 to all the positive numbers. But pretty much, like I said, this part right here and this part right here pretty much is going to be the same every time. It's just this part that will change depending on your answers that you get when you do the math. We good so far? Won't change it. Only got 2 more problems and then we'll take a break. That's kind of what this is, but it's not a tablet. It's still touch screen, but I didn't want the breakaway. Yeah. Yeah. Good. They just replaced mine. Mine would look like that. I just got this one. Personally, I hated this. And I was like, can you just give me my old one back? All right, so in this situation, we have the absolute value of 5x minus 1 greater than or equal to a -1. Correct. So here's my question to you. Can you think of any number that could not be greater than -1? No. Since we know absolute value has to be positive, every number you come up with will be greater than any negative number. So like what we've seen with a less than and a negative, that was a no solution. We saw a equals with a negative, that was a no solution. But this time, when you have a greater than and a negative, how do they write this? I want to call it infinitely many solutions, but oh, they don't. They don't call it anything. Okay, well, I'm going to say infinitely. I don't know if that's how you spell it. Many solutions. So, great question. When you write it in interval notation, it will be -infinity to infinity. to represent every single number known to man. Also, they want you to graph this. Here's 0. This is the graph. Literally everything. So anytime you have a greater than and a negative, it's infinitely many solutions and goes from negative infinity to infinity, and you just shade the entire line. There's no actual work to do. Right. Absolutely. All right. Last question. Absolute value of 3x plus 2 plus 1 greater than or 8. Greater than or equal to 8. What do I have to do first? How do I do that? Good. 8 minus 1. Right. Because it's a greater than, this is an or situation. So this is going to become 3x plus 2 greater than or equal to 7, or 3x plus 2 is less than or equal to, because you flip the inequality sign and change the sign of your number. So it'll be less than or equal to negative 7. So what do I do first? Minus 2. Very good. So we can just leave it like that. All right, how do I solve the other one? Very good. Negative 3. Perfect. So now when I graph it, 5/3 is 1.67, or 1.6 repeating. That's going to roughly be about right here. Will it be a parentheses or bracket? Bracket. And what direction will it shade? Very good. -3, parentheses or bracket. And which way will it shade? To the left. How do I write this in interval notation? Perfect. You're good. So again, notice this part right here and this part did not change, only the numbers that we got in our answer. 5/3 is roughly 1.6 repeating. So I put it between 1 and 2, give or take, somewhere in that ballpark range. Yeah. Yeah. Get this as a decimal. It gives you like 1.6 and like a whole bunch more sixes and stuff. I'm not going to write 3 6s though. Yeah. All right. Oh, when we graphed it, yeah. Yeah. Oh, yeah. That was 9.7 that you also, I didn't record, but it's in here now. Yes. Yeah. Yeah. But the notes are there. I just didn't record it. All right. So we're going to go ahead and take, let's roughly say a 5-minute break.